that better? Okay. Thank you. Good afternoon. Thank you for having me today. Also want to thank EBROM, ECOM, and ECROM for putting on such an incredible event. I think in my 30-year career, I've never seen so much interest in museum fire protection. So you're doing a good job. So today I'd just like to be able to share with you some of the fire experience that we've had at the Smithsonian, some of the lessons learned, and also some of the fire protection strategies that we've developed over the years. And I'm hoping it's useful and applicable to your museums. So unfortunately, as we've seen throughout yesterday and today, sort of an unending number of examples of why fire is the greatest threat to our museums and cultural properties. In the U.S. alone, we have an average of 70 museum fires a year. 70. No, some of them are small museums, some of them are large museums. The Smithsonian's no stranger to fire either. One of our first fire, probably our first fire, was the Smithsonian Castle back in 1865. Some workers connected a wood stove to an existing flue, but they never looked at where the flue went. The flue went into the attic. It didn't go through the roof. So when they first lit up the wood stove, the hot embers went up into the attic, ignite the wood attic. Of course, back then we didn't have any type of fire detection, didn't have any fire sprinklers. All we had were fire buckets filled with frozen water, because it was in January. So the fire destroyed the roof and the third floor of our museum, our first building. Destroyed over 200 American Indian paintings. Destroyed most of the papers of our founder, James Smithson. But the castle was rebuilt and hasn't burned down since then, so that's good. And we fast forward to 1970. This is our American History Museum in Washington, D.C. We had an exhibit with one of the first IBM computers. Back then, our museums weren't sprinklered. We didn't have smoke detection. And we didn't have any regulations on the type of materials that are used for exhibits. So we had, we believe, an electrical fault in the exhibit. The fire spread throughout the entire gallery, consumed everything in the gallery. The only thing that stopped the fire from spreading to the rest of the museum were a set of fire doors. So this picture is taken from outside the gallery. Behind those doors is the gallery that burned. And these doors held the fire in check for about 45 minutes until the fire department could actually extinguish the fire. The one good thing that came out of this fire is that the Smithsonian decided to start a fire protection program. And that's why I'm at the Smithsonian now. And since then, we've been putting in fire alarm detection systems, fire sprinkler systems, developing policies on to limit combustibility of materials. So I'd like to just talk about developing fire program, fire strategies, fire protection strategies. So one of the first things you want to do is look at your causes and contributing factors in museum fires. Now, these numbers here are based on U.S. statistics, so fires in U.S. museums. But by far, cooking is the #1 cause. I'm not sure if in Brazil it's the same. But then followed by smoking, heating, and electrical. And in terms of contributing factors that allow a small fire to grow large, to become a devastating fire, we see a number of repeating contributing factors. Lack of fire compartmentation, continuity of combustibles throughout the building, a lack of automatic suppression systems, delayed discovery of the fire, either because there's no fire detection or because the fire detection is not monitored 24 hours a day, so it's not going to, if you have a fire in the middle of the night and your fire alarm system's not monitored, no one's going to know about it. And then combustibility of the building itself as well as the exhibit materials. We also want to make sure that we don't get misguided by myths about museum fires. I always hear people in the museum world say, well, my building's non-combustible. We don't have a problem. We don't need additional fire protection. And we try to tell them, well, that's actually not true. So everybody knows this building, Museum of Modern Art, right here in Rio. It's all concrete and glass construction. But in 1978, it had a devastating fire, destroyed, from what I hear, about 90% of the collections. So this is a picture of the museum after the fire. So just want to dispel that myth. You also hear a lot of times, well, the fire department's right next door, or it's right around the block. We'll be okay. Again, I think in one of the earlier talks yesterday, we saw how quickly a fire can grow. I mean, within minutes, you can have an entire space this large involved in a fire. And it's going to take at least minutes, several minutes, for the fire department to get there. So just having the fire department shouldn't lull you into a false sense of safety. Fire prevention programs are extremely important, but it's not the entire solution. From everything I read, the Notre Dame fire, they had strong fire prevention programs, but still, they had a devastating loss to their cathedral. And then also, I think this was covered yesterday too. About you read in the news about a fire, and they say, and the building was sprinklered, and they say, oh well, there's this many dollars worth of fire damage, and an equal amount of water damage from the sprinklers. What they don't say is, well, if you didn't have sprinklers, how large a fire would you have had? You would have had, an exponential amount more fire damage if you didn't have sprinklers. So in terms of developing a fire protection strategy, you want to first start out with, identifying your goals and objectives. I think probably most people agree that life safety is going to be your highest priority. For us, for Smithsonian, it's protecting the collections is probably our second priority, protecting our facilities, and then protecting the mission of the Smithsonian and the continuity of operations. So those are our objectives. And then you also have to look at what your risk tolerance is. How much are you willing to lose? Right? You want to design your fire protection systems and your fire prevention programs so that you control what your maximum possible loss is. So I always like to start out with a little bit about life safety because it is extremely important. It's extremely important in assembly occupancies like museums. So you always want to make sure you have adequate egress paths, that your stairwells are protected, enclosed, and fire-rated construction, that you've identified your assembly area so staff know where to go in an emergency. You want to have an emergency plan that identifies all the procedures and each staff's person role during an emergency. And you don't want to forget about people with special needs. People who are hard of hearing, people that are in wheelchairs. You want to make sure that you have a plan to be able to get them out of the building. Also, special events. Almost every museum seems to have special events, and this is where you're really pushing the envelope from a life safety standpoint. A lot of times it's when you have your highest occupant load for a really large event, Sometimes you're using areas that aren't normally assembly spaces for a special event. Often we find that egress gets obstructed. Either they're building a temporary stage in front of an exit, or you have caterers who are setting up their cooking operations in a corridor. So you want to keep an eye on those things. A lot of times caterers want to bring in cooking equipment and cooking fuels into your building. And for us at Smithsonian, we don't allow any propane or fuel gases in our buildings. And we saw that cooking was the #1 cause of fires in museums, at least in the U.S. Open flames like candles, you want to control those. And actually you have to look at decorative materials. A lot of the decorative materials that are brought in for a special event, banners, drapery, can be highly combustible. And often you can find fire retardant alternatives. So life safety is one part of your fire protection program. Then I like to look at fire prevention and protection as a three-legged stool. You need all three legs to have a working program. So the first leg is your fire prevention programs. Second leg is detection and suppression. And then the third leg is fire containment or fire separation. So in terms of fire prevention programs, those are your cheapest things to implement. Usually it's operational. So it's either low cost or no cost. It's like things like having a safe hot work program. So you're monitoring hot work. Making sure you have, you're controlling combustibles. Are you storing combustibles in your corridors or in your stairwells? You want to have walkthroughs by someone in your museum who's looking at safety to make sure that they're catching these type of things. You want to isolate your hazardous operations, like a wood shop or your flammable liquid, use of flammable liquids. Put those in a separate fire-rated room. Keep an eye on exhibit construction. I'll go a little bit more into detail in a second on that. We talked about special events. And also for outlying museums, you have to worry about the wildfires. Making sure you cut back shrubbery, overhanging branches, closing up openings on the outside of your museum. So exhibits can introduce potential hazards to your museum. And we've seen a number of fires, both at Smithsonian and elsewhere, where exhibits were a really contributing factor. So one thing is you have to make sure that the exhibit designers are aware of the egress requirements, that they're not obstructing exit paths or exit signage. Whenever an exhibit is being installed, that's temporary construction. Temporary construction always introduces hazards into your building. Additional combustibles, could be additional ignition sources while they're building the exhibit. You want to keep an eye on combustible materials. We review all the materials that are being used for interior finishes and casework to limit the combustibility of them. Nowadays, exhibits have a lot of electrical equipment in them, and those are ignition sources. You want to make sure electrical is being installed correctly, and making sure that your exhibits aren't interfering with your fire detection or your sprinkler systems. So this is just an example of some requirements that we use for our exhibit designs in terms of limiting flame spread or combustibility of interior finishes, anything that's going on the walls or ceiling. You want to also look at the smoke developed ratings of these materials that you're putting into the building. We also apply these standards to really large cases, over 100 cubic feet. Just a note about plastics and foams. Our exhibit I think probably most exhibit designers probably love plastics and foams because you can be very creative, right? Actually, this whale is partly made out of foam. But the problem with plastics and foams are They're easily ignitable. They produce copious amounts of smoke. And when they do burn, a lot of them melt and form pooling flammable liquid fires. So we always encourage our exhibit designers to try to look for alternative materials, whether it's, you can get fire retardant fiberglass, and there's other materials that you can use instead of foam. Not to say that we don't use any foam. I mean, sometimes we do, but you can either get foam that has a fire retardant in the that's introduced during the manufacturing of the foam to make it more fire retardant, or in case of this whale, we actually coated the entire whale with a hard fire retardant coating so that it wouldn't be easily ignitable. So that's one. So fire prevention is one leg. Second leg is fire containment or fire separation. That's used to, one, maintain the structural integrity of your building, to protect the steel, to keep floors from collapsing, for enclosing stairwells to make sure they're safe during a fire, for compartmentalizing a building into fire sections so that to keep a fire in check so that the fire doesn't spread throughout the entire building. And also for enclosing hazardous areas, it might be a flammable liquid storage area or a wood shop, something like that. We also use fire-rated walls and floors and ceilings to enclose our collection storage areas, and we use 2-hour fire smoke barriers for that. Fire detection and alarm systems. The benefits of having a fire detection system is, you have 24-hour separation, so you have early warning of a fire. That means you can get people out quicker. You can get the fire department there quicker. You can also use your fire detection and alarm systems to control fans, close fire doors, and close dampers to prevent fire spread and smoke spread. These are just some of the types of fire detection systems that you can use. First is heat detectors. Heat detectors give you a slower response than smoke detectors in terms of alerting you that there's a fire, but they are good for areas where you have dusty environments. Spot type detectors are very common. We have them in here. You see them in a lot of museums. We use them a lot. You also have beam detection, which is you have a transmitter and a receiver, and it sends a light beam across an area, usually used in very large halls or atriums. And more state-of-the-art is the air aspirating smoke detection systems, and we're using these now in we've started using these in our collection storage areas because they detect a fire extremely early. Even before you might smell the smoke, these detectors can pick it up. We also found that they're very useful in high ceiling areas, so like our galleries with really high ceilings. Instead of having to send our maintenance crew in with lifts and long poles over top of the collections, they only have to go to a central detector, which is usually in a closet, to maintain the system. Fire suppression systems. The benefits of having sprinklers are you have an automatic response. You're not waiting for the fire department to show up. Sprinklers are heat activated, so they're not just going to go off because there's dust in the air or for something else. You have to get a temperature of about 165 degrees at the ceiling before your sprinklers are going to activate. You get a fraction of the volume of the water released by sprinklers versus fire department. A fire hose. Sprinklers will put out somewhere between 80 and 180 liters per minute, where a fire hose is almost 1,000 liters per minute. If I got my conversions right, I think that's right. They're fairly low maintenance and extremely reliable. So Smithsonian has about 16 million square feet of museums and research centers, and about 90% of our facilities are protected with sprinklers. And we've had a very good experience, You can't guarantee that a head will never go off accidentally. It can happen. But you look at, so if the worst case is that happens, you get a small area wet. Versus if you don't have automatic sprinklers and you can't control the fire, then you could lose, an entire gallery, entire wing, or entire museum to the fire. There's a few different types of sprinkler systems. Wet pipe is probably the simplest and lowest maintenance type of system. So with the wet pipe system, all your piping is filled with water. The system's always charged and ready to go. When you have a fire, the head over the fire is heat activated, but the other heads stay closed. So you're only opening heads that are directly over the fire. And from fire experience shows, most fires are extinguished with 1 or 2 heads. So you're really not using more water than you have to. There's also dry pipe systems. So dry pipe systems, the piping is filled with pressurized air. The water is held back at the base of the system by a valve. When the head opens, the air pressure drops, the valve opens, and water flows through the piping. We use mostly wet pipe systems. But we do also have pre-action systems. And this is an option, in areas that are very sensitive to water damage. So pre-action systems are sort of like a dry system where the piping is filled with air and the valve is holding the water back. But you also have your smoke detection system in the area as well. And when the smoke detectors activate, they release the valve. Then the pipe fills with water. But you still don't have a water discharge yet. And then the heat activates the head, and the head opens. So it takes 2 operations before you have water release. The advantage of pre-action systems is that if someone accidentally knocks off a head with a lift or a ladder, that you're not going to get water flow. The downside of pre-action systems is that they're higher maintenance and higher cost. Just a couple sprinkler myths. All sprinklers activate at once, right? We heard that yesterday, right? That's only in Hollywood. Systems will discharge as much water or more than a fire department. No, that's not going to happen. They're incompatible with historic buildings. We have a lot of historic buildings. Several of our museums are over 150 years old, and we've been able to fully sprinkler them. It's a little bit more expensive, and it takes a lot more thought to do it sensitively, so you're not impacting the historic fabric or minimizing your impact of the historic fabric, but it can be done. Sprinklers are ugly. Well, being a fire protection engineer, I know that's wrong. But, but actually, sprinklers can be hidden. The piping can be right above ceilings or in walls. They have concealed heads where when you look up, all you see is a round disc, and that's it. So, if you leave it up to an architect, they'll find a way to hide it. So, other options in terms of automatic fire suppression: water mist systems, clean agent gaseous systems, wet and dry chemical systems, and hypoxic air systems. All these systems are really geared towards a specialized application. Wet and dry chemical systems are really more for like kitchen hoods, that type of thing. Water mist, I have seen water mist used in some museum galleries, like National Gallery of Art in Washington, D.C. has a few water mist systems. Water mist is great from the standpoint that it discharges only a fraction of water that sprinklers put out. The downsides are they're very expensive and they're higher maintenance. Clean agent systems like, used to be halon, now they have other agents like Energen, FM. So those are agents that totally flood a room. You have to have a very tight construction to contain the gas in the room. They're very expensive, and it's sort of a one-shot deal. You have tanks of gas, they discharge. If someone leaves a door open or something like that, then you don't reach the critical concentration and the system may not work. We do have some clean agent systems, and we actually back those up with sprinkler systems. Hypoxic Air Systems, this is at our American History Museum, and it protects the Star Spangled Banner, which is probably one of our most iconic artifacts. Basically, it's a chamber where the oxygen is kept at 14.5%. I think this was the first hypoxic air fire protection system in the United States. And it was very expensive, and we had a lot of lessons learned. It required a very, very tight chamber to keep the oxygen level at that level. And what we found was we didn't build it tight enough. And then it overworked the system that scrubs the oxygen out of the air and burnt up our compressors, and then we had to replace all the equipment, and we basically did it all over again. So this is a very specialized application. Fire extinguishers, talked a little bit about fire extinguishers earlier. There's various types. The most common type is the dry chemical ABC type extinguisher. Works on most types of fires. The downside of dry chemical, from what I've heard from collections staff, is that when you have a discharge, the powder is so fine it becomes airborne, and it travels very far and makes a big mess, and it's very hard to clean, and it also can be corrosive to metals. And because of that, in our collection areas and in our galleries, we've gone to water mist extinguishers. So water mist extinguishers can be used on ordinary combustibles and even electrical fires. Just can't be used on flammable liquids. But according to our collection staff, they can recover artifacts better if they get wet than if they get contaminated with a dry chemical for most materials. And there is a study that was sponsored by the Fire Research Foundation, and they've actually gone through and they applied all these different agents to different types of collection materials, and then they looked at the reaction of those materials to those agents over time. It was conservators looking at it. So it's a very interesting study, and if you just Google Fire Research Foundation extinguisher test, it'll come up. I know I don't have a lot of time, but see what I can cover here. So, for protecting collections, you want to make sure your collection and storage areas are enclosed in fire-rated construction. From a fire prevention standpoint, you want to limit your operations in your collection areas. It's better not to do your packing and conserving in your collection storage areas. Try to, because those operations just introduce more combustibles and more ignition sources into your collections area. So if you can limit your collection storage areas to just collection storage, your collections are safer. For us, as I mentioned before, just about all our collection storage areas are sprinklered and have either spot type smoke detection or the air aspirating smoke detection. We also limit the size of our collection storage areas to 30,000 square feet. This goes back to what your risk tolerance is. How much are you willing to lose? If your sprinkler system fails, if your hydrants fail, how much are you willing to lose? For us, we chose 30,000 square feet. I'm going to keep moving on here. We do have a few, I mentioned that, but we do have a few of our collection storage areas that are protected with gaseous agents, but also sprinklers. So you want your collection storage rooms to be dedicated for that purpose. Avoid processing, packing, conservation. Try to use non-combustible cabinets and shelving where you can. We've found a lot of collections staff want to line the shelves with foam, You know, it's a great material in terms of it's soft, it helps protect the collections, but if a fire does start, the fire is just going to travel all the way down the shelving. So try to minimize use of foam. And also you want to be careful about sometimes your collections themselves are the hazard. Cellulose nitrate film, wet collections in ethanol, you want to make sure those are separated from the rest of your collections. Just a note on resources. So, you know, your building and fire codes are a great resource, but something to keep in mind is that your building codes, they have two goals, life safety and firefighter safety. It's not about property protection. It's not about business continuity. So you may need to go above what the codes require to achieve your goals. Some other resources, Nfpa 909 is a code that's written exactly for museums, libraries, and places of worship. I'm on that committee that writes that code. Nfpa 914 is for historic buildings. And also in the Life Safety Code, there is a section on historic structures. So also, the Smithsonian, we've developed a manual, design construction manual for fire protection and life safety. And this is actually available online. You know, we have fire protection system design criteria for fire alarm systems, fire suppression systems. We have guidelines for collection storage, as well as for exhibits. So this is a nice resource for museums. So in conclusion, you want to identify your goals from a fire protection standpoint. Always remember life safety is going to be probably your top priority. You want to establish your fire prevention programs. You want to evaluate and address your fire containment, fire separation needs. You evaluate and address your fire detection and suppression needs. And then develop and implement an implementation plan. You know, this is something you can't do overnight. It's going to take years. I mean, we've been putting sprinklers into our museums for the past 30 plus years, 40 years, and we're still not done, but we're getting close. So you have to come up with short range and long range goals to implement your plan. Thank you very much.